Okay, hello, good morning and good evening. My name is Zhao Qin. I'm from F5 Networks. And today I hope to introduce our new open source product, which is the F5 ADCaaS service for OpenStack. So that is a new product of F5 which can enable you to consume the F5 load balancer and VAR functions with OpenStack Cloud. So today I will go through this content. First, give a brief background, and then I will introduce the architecture and use cases. And finally, I will give you a lab demo to introduce how you can provision the big IP device in OpenStack Cloud and deploy your configurations. So first, let us have a look at the background. So if you know F5, you may know the major product of F5 is big IP, so which is the application delivery controller. Can offer the load balance functionality and firewall functionalities. So F5 used to have the OpenStack LBus V2 driver agent, which can running inside of OpenStack and help you to doing the configuration works of F5 big IP hardware. But the current situation is the legacy LBus V2 API of Neutron LBus has become deprecated and will be retired soon. So that we have to move to a new architecture, which can offer you a better user experience and the whole functionality of big IP. The plan for this new product is that we need to release the first version in September this year. That is the fourth quarter of financial year 19. In that version, our application will offer you the big IP virtual edition onboarding functions. And also it will support to configure the F5 buff policies, upload the policies to the device and deploy the configuration so that you can experience the VAR function. And for the most important function of LTM, that will be implemented in near future. The LTM function will not be included in our first release, so that unfortunately you might need to wait for a while and wait for our next release to consume the LTM function. So next page is about the architecture. So this diagram illustrates the basic architecture of our application. So there are two major differences from the existing Airbus V2 architecture. If you know that, you may know the legacy Airbus V2 agent driver are running inside of OpenStack, so that the user can just invoke API of OpenStack to provision the applications and configure the load balancer. But the new architecture decoupled our application from OpenStack. That means F5 will offer a separated application set, which provide the new API so that the users need to provision this set of application cluster running on the side of OpenStack, and they can, as usual, they can provision their own applications via the OpenStack API, but they need to invoke L5 API to doing the configuration works of Big IP. Another difference is the existing Airbus V2 driver agent only support the Big IP hardware device, and the new ADCaaS service will support hardware and software both. That means you may be able to doing the configuration against the Big IPv running inside of OpenStack, and you will also be able to configure the Big IP hardware. But in our first release, the first release will only support Big IP virtual edition. Yeah, the hardware support will be implemented in near future. So in the next pages, I will briefly introduce use cases. The use cases will be described with personas. So we will have 4 types of personas: the network admin, security admin, the application developers, and DevOps developers. So this page shows you the typical use cases. So before the tenant user, that is application owners and DevOps developer, before they can consume our ADCaaS service API to onboard the Big IP device, before that, the net admin and the security admin have to prepare the public resources for tenant users. So our assumption is that the net admin need to prepare the Big IP image in OpenStack. He may also need to create the public flares and the networks for tenant users. And also the security admins may need to create and publish the public WAF policies for all tenant users. Those are the preparing stage. And after that, after all the public resources are available to use, the tenant users will be able to use our API in a self-service way to onboarding the Big IPv4 device and deploy the configurations. The tenant user may have 2 selections. The first selection is treated in this chart. You can see this path. The first selection is doing the automated configuration deploy by our API. Basically including 3 steps: onboarding the Big IPv4 instance, upload the WAF policy, published WAF policy from the policy repo to the target V instance, and then they can create and deploy the configurations. That is automated parts. And we also support a manual parts. If the users are very familiar with the Big IP configurations, they may only utilize our API to onboard their Big IP instance in OpenStack, and then they can, use the Big IP web GUI or command line to manually configure the device. One thing need to be noted here is these 2 paths cannot be mixed. That means if the user choose the automated path, they will not be able to use the manual path to modify the configuration. If the user choose the manual path, they may not be able to continue to use automated paths to modify their manual configurations. So we cannot support to mix these two paths. The user need to make their selection at the beginning. If they hope the automated configuration deploy, they can follow our API to save their configurations in DB and continuously to deploy the configuration to the device. So the following pages describe the steps in a little detailed way. So first, let me see, this page is about the network admin. He can, in order to prepare the Big IP device image, he can download our official Big IP image from F5 official site, and they need to, utilize the API of OpenStack to upload the image to the image repo. And maybe he also need to create the flavor for the Big IP device, and also create the networks for tenant users to provision the device. The onboarding process requires the Big IP to connect to 4 different networks, which is the internal network, external network, management network, and the HA network. The next page is about the security admin. The security admin is responsible to create and publish the WAF policy for tenant users. We have to stress that currently only Big IP ASM web GUI can create the complete WAF policy. So we will not have another separate web GUI or API to do that. That means the security admin must have an existing Big IP device, log into the web GUI using ASM to create the WAF policy on that device, and then import the policies from the device to a local XML file. It can upload that file from the local file system to a remote file repo. For example, you can upload that XML file to GitHub, GitLab, or some other file repo provided by the user. And then after the WAF policy file is available to use, the security admin can use our API to define a policy resource for all tenant users in OpenStack. That API only requires him to input the remote URL of that WAF policy. So after those public resources are ready to use, the tenant users can be able to provision their own Big IP device in their own tenants. So OpenStack, as you know, is a multi-tenancy application. That means the every users can independently use the self-service API or web GUI to provision their own Big IP device in their own tenants. All of those Big IP VE device running in OpenStack are independent. So this page show you a basic workflow. The first, the tenant users may get their token from OpenStack Identity Service, and then they can use that token to invoke our API. that is something like a one-click button. So after the user describe their big IP device and upload that definition to our API, our applications can do all the following works, including create the network resource in Neutron, create the virtual machine by Nova, and also we need to install the declarative onboarding RPM and AS3 RPM on target device in order to implement the future configuration deploy. So eventually, the tenant user will see a new virtual machine, which is the BigIPV instance running in their OpenStack tenant. And that machine will have DO and S3 installed, and so that it is ready to accept the declaration configurations from us. In order to implement the device onboarding, the user must have an BigIQ running on the side, which acts as a license manager, so that during the device onboarding process, the new device can acquire the license key to activate itself. Okay. After the tenant users successfully onboard their devices, they can continue to invoke our API to upload web policies to the target device and then deploy the configurations. So those flows are much more simpler. Yeah, you can see in the page, just one API call to upload the web policy to target device, and then the tenant users can continue to utilize our API to create the configurations and deploy the configurations. I will describe those steps very detailed in my lab demo. So the previous pages introduce the automated configuration deploy path. And if some of the tenant users hope to choose the manual path, that will be fine. But if you choose the manual part, you must onboard the BigIPV device with your SSH key, because the OpenStack is a multi-tenancy cloud, so that in that environment, every BigIP device should not have a default admin key, so that in device onboarding process, the default BigIP admin key will be replaced by us, so that the user may not use the default passcode to log in the BigIP web GUI, so that the user have to onboard the device along with their own SSH key, and after that, the user after the device is ready to use, the users will be able to use their own SSL key to log in with root credentials to the BigIP device command line, and then they can by themselves to reset the BigIP VE admin password via the command line, and then access the BigIP VE web GUI. So that have to be done by themselves. Okay, so now is the time for me to give you the lab demo. So 1 second, let me stop the presentation first, and then move to the Postman web GUI, because our product have not yet support web GUI, so that we have to do this demo while Postman using the REST API request. So you can have a look at my demo environment first. I have OpenStack running. Sorry, let me log in this. Let me log in this OpenStack console first. Okay, I log in into the OpenStack console, and you can see there is an empty tenant, right? This is my demo tenant. After a while, I will provision my web server and big IP device in this tenant. And also, in this window, I have a big IP device running. Let us log in this big IP device. Okay, so this is the lesson manager of BigIQ. In this demo, I will use this pool. This is a lesson pool, which includes one active lessons. In this demo, I will use this lesson pool to activate my device in OpenStack. So, okay, let us move back to the Postman. Okay, sorry. Okay, in Postman, I have a collection of REST requests. So this demo will have 4 stages. The first is preparing stage. In this stage, I will call some REST API to prepare my demo environment. And after the environment is ready, I will show you the BigIPV onboarding process. And then I will create and deploy simple configurations, including WAP policies to that device. Okay. Eventually, I will show you how can we access the VIP of the BigIP device, and that can prove that we can connect to our backend web server. Okay. So let's move to the preparing stage first. So at the very beginning, we need to get a new token of keystone. Okay, that's fine. And yeah, because I have already run this test before this lab demo, so that we can skip some of the steps and go directly into the create web server. Yeah, this step. This step can help us to create a web server as the backend pool members of BigIP. So the API request is done. So let us move to OpenStack console to see what happens. Okay, this is the web server created by our API. So in the demo, it will become our backend web server in the pool of BigIP. Okay, so our web server is ready to use, and I will occupy an IP address. So this step is just to occupy an virtual IP address as the VIP for the future test. Okay. So the environment is ready. Let us start the onboarding process. This is our REST request to create our new Big IPv instance in OpenStack. So let us have a look at this request. All right. Yeah, this is the request body. So it's not very complicated. You may need to specify your 4 networks. You can see here, management network, the failover network, internal network, and the external network. So every Big IPv running in our tenant will need to connect to these 4 networks. And it also requires you to input your Big IP image and Big IP flavors. Those two should be prepared by the NetAdmin. Okay, let us click the button. Okay, our request is done. And from the response, you can see we have a new Big IPv device created. And let us move to the OpenStack console. Okay, you can see here is the new Big IPv device created by us. This device connect to 4 networks. Okay, the status of the device in OpenStack is active now, but in fact, the device is still being initializing, so that we are not able to are not able to configure this device right away. We have to wait a little while. After the initial initializing is done, we can move to the next step to create and deploy the configurations. Okay, so maybe we can have a quick look about the state of this device. Okay, from the API, the current status of this device is powering. That means the Big IP is booting in OpenStack now. So maybe we can have a look at the device console. Okay. Yeah, it works. So you can see in the device console, you can see this new device is booting now. So we have to wait here and have a couple of minutes, maybe. Okay, yeah, very quick. Now, in the console, we can see the login screen of the Big IP device. But we need to move back to check its status again. Okay. Oh, it's very unfortunate that the status is still pouring. That means the initializing has not been done. Although we already see the login screen in device console, but because our application have to doing some background configurations during the booting, that means there is currently an application running in this device background to do the initial setup. So once this initial setup is done, the status of Big IP will become onboarded. So that means we have to wait a couple of minutes and wait for the status to become onboarded. Maybe maybe take 2 or 3 minutes. Let us check it again. Okay, we got a response. Oh, you can see the status become onboarding now. Yeah, that means the initial setup is still running, and we are a little nearer to the target. Let us waiting for it to become onboarded. Oh, okay. If someone become tired, you can have a cup of coffee, maybe. But it's very unlucky that I will not be able to have a cup of coffee right away because I need to repeatedly click the button to check its status. Hope it can complete very soon. Still onboarding, so maybe maybe I can mute my microphone and then move back. Oh, okay. I'm back. Just now, I had some water. Hope the device is ready to use. What happens? Still logging. Maybe we can move back. Sorry. Check it again. Oh, okay. Onboarded. That's fine. Yeah, we success. Onboarded. Okay, if the status of this device become onboarded, that means the very initial setup is done, and then we can, yeah, this should be the management network. Yeah, let me check. The management network. Okay, so that means we can use the IP of management network to access this device. Sorry. Yeah, okay. We can see that the big IP web grid is running, and we can log in the web grid. In this demo, I do not let my application to override the default password of big IP, so that I can use the default password to log in this web console. And in this console, we can see that the device is running, but it has not any configurations, right? No configurations. So we will not use the web console to configure the device. We will choose the another path to utilize our API to configure the device, so that I log out that web console and move back to our Postman. So after the device become onboarded, there is another API call to install the AS3 RPM on this device. So let us trigger that API. This will not take very long time. We can have a check. Okay, installing. The status installing means the AS3 RPM is being installed on this device currently. So maybe we need to wait for 30 seconds, maybe. Let me have another tag. Okay, active. Okay, that's fine. So the status of this device become active. That means everything is done. We already have the initial setup complete and also have the S3 installed on this device. That means we can move to next stage. And deploy declaration stage. In this stage, we will be able to create a set of configurations and deploy those configurations to the target device. Okay. So before we do that, let us move to another web page. Here, yeah, here is a web page of our core resource models. Okay, in this diagram, you can see in our applications, we define a set of core models via REST API. Because our app will utilize the S3 declarations to config the big IP device. Every S3 declarations is very large, it's very complicated, so that our application will not require the user to write their own S3 declaration by themselves. Yeah, the user need to utilize the REST call to create a set of resources one by one. And after this set of resources is created, the user can click another button to translate these resources into an S3 declarations. Okay, so that user experience will become a little simpler because the user may not need to write down the declaration by themselves. Just click a button to create the core resources, and our app will doing the translation. So let us move back to Postman. I will show how to do those configuration. So if a user hope to deploy a load balancer to this device, he need to at the very beginning create an application first, and then the application may need a default pool and one pool member. Okay, you can see the pool member IP should be the web server IP that we created in OpenStack. And we will have pool monitors and member monitors. So that means we have two monitors, one for pool, one for one for node. And after pool is ready, we can create the service. The service will become the virtual server in big IP device. Okay, so then And in this demo, I will also show you how to upload WAF. So in order to implement a WAF, you need to create the endpoint policy and also create the rule and actions. Okay. Because we need an WAF action, so that we will upload the WAF policy to that device. Currently, there is no there's not any policy stored in this device because the device is just provisioned by me. You can see this screen. Just now I define a WAF policy via the REST call. In the body, you can see a URL link to GitLab repo. That is a simple WAF policy for our demo. So after that, we can upload this WAF policy to our target device. Click the button. Okay. Success. And this uploading will take several seconds, and we can do a check. Okay, applying. Okay, that means the file has been uploaded to the target device, and ASM is currently applying this policy. Maybe we can have another check right away. Okay, yeah, very quick. The policy become available. That means we can move forward to create the WAF actions. Okay, so at this point, we have our application, pool members, monitor, service, and the WAF actions ready. That means we can move next step to create our declarations for this application. Click the button. Okay. And in the REST response, you can see we have a declaration object created in our database. Please note that at this point, this configuration is created in our database, but it has not been deployed to our device. So currently, our device is still empty. Yeah. So in this declaration resource, you can see in this column, the content property is an S3 declaration. This declaration including our virtual server definition with the virtual address, and also it has our default pool with one pool member, and then it is the WAF action. Okay, and this is only the declaration of one application. If user hope to create the configuration for several different applications in the same big IP device, they can use our API to separately create other application and declarations. So our application support to deploy the declarations of different applications independently to the same target device. But in this demo, I will just create one application. Okay, we have our declaration ready, and then yeah, here we can click the button to deploy this configuration to the target device. Oh, sorry. This is the virtual IP that I occupied. Forgot to release this big IP before deploy the configuration. So that is very easy. We can move to this step. Very simple. Yeah, because that virtual IP is occupied by me before this demo. So we can release this IP and deploy it again. Yeah, okay, it's done. Yeah, the response is successful. And then we can use the virtual address to access our backend server now. I hope we can succeed in one click. Hope me have good luck. Access VIP. Let me try. Okay, this done. Yeah, you can see the response from my web server. We use the virtual IP 116 to access the server, and our server have its response to me. The IP address should be an internal network address. Let us move back to the OpenStack console to check that. The address should be 169. Yeah. Yeah, it's here. Yeah. That response is from my backend web server. Yeah. And we can refresh this console again to see what happens here. Now you can see that in the external network part, currently the big IP have two IP address assigned. One is self IP and another is the virtual address. The virtual address should be 116. Yes, this one is the virtual address. Okay. So because we deploy this configuration with and policy, so that I have another check to verify whether or not this WAF policy is working, right? So in this call, it proves we can access the virtual address, and in the next call, we can use another HTTP request to prove the WAF policy is working. For example, this call will have a special header, and if the header is here, the ASM WAF policy should block my request, right? Let us check the result. Yeah, you can see this response is not from my web server. This is from the BigIP device, because I have a web policy defined for this VIP, so that the BigIP device block my request since I have a special header. So this request prove my configuration works very well. So we can continue to click the button. Yeah, we can click the button to prove the web server is working. It can respond to the right HTTP request. But if the request is not right, the WAF can block the invalid request. Okay, that prove my configuration works. So after this check, maybe most of the contents of my demo complete. But at the end, I hope to let you to go into the BigIP device, because I assume that some of the users hope to see what is the configuration deployed to this device. Let me move back to the device web GUI again. So, okay. So in this console, you can see nothing because we are in the common partition, right? So those configuration done by our app is deployed to another partition. That ID is the tenant ID of OpenStack users. So in this partition, we can see, yeah, the virtual servers is running now. The color is green, and we also have pools running, and we also have here should be ASM, right? Sorry, everything security policy. Yeah, here. This is the policy uploaded by me just now. So here you can see action is blocking, right? The policy for SM demo. Yeah, that is the right policy uploaded by me. So at the point I think most of the audience should know we can utilize our API to complete the whole configurations to deploy the applications with that policy, and we have a simple check to prove the policy works. That should be the demo I provided for you today. So hope to have a nice day. Goodbye.